This is ORD survey webinar number 12. We're going to continue with mapping and point cloud workflows this week. And it's hard to believe we're been doing this since July, but here we are. I'm Jonathan Rawlings. I am a project surveyor here in Geometronics. We have talked about quite a bit. I'm not going to go through all the lists that we have talked about. I would like to thank Rhonda and David for stepping in when I was gone over the past 2 weeks. First week in October, last week in September, talking about blue marble and reprojecting LAS files. And that was Rhonda's topic. And then David talked about the UAV LiDAR systems and the testing that he's done on that. And hopefully that's going to be coming down as a tool that we use more often in the future. I think it's going to be very useful. And today we're going to talk about 2D mapping in TopoDOT. It's really a continuation of a topic that I intended to get to before I left to go on vacation and before Kevin did his webinars on the right-of-way side of things. And then I've got 4 more topics on there that will take us to the end of the year. So we've got the new cadastral workflows in ORD setup, and Kevin's going to do a webinar on that. I was going to get into the reality modeling tool details in a webinar that will be towards the end of November. And then in December, we're going to do a webinar on how to use the attributes in the controller in the field. And then another webinar on the new static scanner that we have, the RTC 360, which I think is going to be a valuable tool to use on intersection projects specifically, but it can be used anywhere. And that will actually take us to the end of the year. So we're going to move to doing these every 2 weeks. That gives us time to process them and get any kind of other things done that we need to get done. Doing them every week is a little bit cumbersome for getting them prepared. So every 2 weeks. And if you haven't been on the East ORD survey workflows page recently, you should know that it now has webinars 5 through 8 uploaded. And Lenny has also kindly provided links to the various topics for each webinar in the description field. So take a look at that and try it out and see how it works for you. So when I say the links, right here, there is some blue text that will link you directly to that topic in the YouTube video. So pretty handy. Thank Lenny for that. She came up with that. So you don't have to search around in the YouTube videos for these different topics. So pretty handy. There's also a new workflow document for editing exterior terrain boundaries in ORD that has been posted. It's right here, a PDF. So please take a look at that and try it out on your projects. And if you find any issues or you get confused about anything, reach out and let me know. Several people have reviewed it. There still could be some holes in it. So please provide feedback on that. Or if it works great for you, we'd like to hear that as well. So definitely go check out the East ORD survey workflows page. We have a process for taking InRoads DTMs to ORD terrains. And back in August in webinar 6, I demonstrated how to do this. And everything has worked fine on my machine, but it was recently discovered that if you're working in the office, you may not have access to the custom style sheet that we built to convert the DTM to a text file. And I had all this set up to show you how to fix that if you're working in the office. It's kind of a temporary workaround. And it was going to be another 2 weeks before that was fixed. But Lenny called me around lunchtime today and said she had fixed it already. So you don't have to worry about this. Just know that if you're working in the office and you want to convert an InRoads DTM to an ORD terrain, you will need to log off your machine and log back on. You should do that every day, but if you haven't, you're not going to get that update to the V8i workspace that Lenny fixed at noon today. So if you have any questions about that, reach out to Kevin or myself. We can help you with the process and making sure that everything's going smoothly there. So, and I do have a Word document that is almost complete. I've got to add in some images and then I will share that with everybody. It'll go up on the East ORD survey workflows page. Last month, before I went on a 2-week vacation, in webinar 7, I talked about the ODOT survey ribbon and using it for 2D mapping. I talked about how the different buttons on the ODOT survey ribbon set the respective element templates. And then when you import these features into your survey fieldbook using the import from graphics tool, you will get a feature with a field code. It's like magic. We also discussed how that worked with the feature symbology and the feature definitions. And I'm not going to go over that again today, just kind of reviewing what I've talked about previously that kind of leads up to what we are going to talk about today. So we then discussed the process for using that ODOT survey ribbon and what I would call the manual extraction method to get your 2D features into a base map. And this is that process shown on this slide. Again, webinar 7 has that process in video. And again, I'm not going to go into that manual method today, but go back and look at it again if you need to, or give me a call and we can discuss. But I wanted to talk about kind of why is any of this important? Well, this is the 2D mapping that we did for Rose Quarter starting back in about 2017. And this was all done before we had TopoDOT. So all of this was done manually using the V8i task ribbon that we're also familiar with. And we were collecting striping, we're collecting gutter, collecting sidewalks, signal poles, signal heads, trees, signs, sign text, poles, utility poles, light poles, parking lots, striping in parking lots, and building footprints. So it was really a pretty extensive effort, and we had many different people working on it. So it became a bit of a chore with managing the different data sets from everybody. And you can see there was a lot of mapping that we pulled from point clouds that we could have pulled from 3D data, but we didn't have TopoDOT. And we just took it and set it at 0 elevation. So all we were left with was our map features that we pulled from a point cloud, set them at a 0 elevation. So we kind of lost that. We lost that 3D data with that. And almost every project that I worked on in Region 1 had a request from traffic or roadway for 2D mapping outside of the 3D requested areas. So most of the paving projects outside of the ADA ramp areas were usually only 2D data. So it's something we really do quite a bit. So sometimes it could be cumbersome with our kind of manual method that I referenced in webinar 7. Oftentimes, you would have your MicroStation file up, you would have Google Earth up or Street View up in another screen. And if you were doing signs and sign text, you were going through, pulling it out of the point cloud in your MicroStation file. And then in your Street View, you were also moving along in your Street View, getting that sign text. So it was a little bit cumbersome. We now have a better method to do all that. And that better method is through using TopoDOT, which we can use for both 3D and 2D mapping. And there's really just 3 main steps for 2D mapping using TopoDOT. And in each step, you will need to create a new DGN file if the project is in ProjectWise. And hopefully you'll see why as we go through this. So the first file and step is to use the seed TopoDOT seed file and create what I'm calling like a mapping working file. And this can be a throwaway file when you're done. There's really no reason to keep it. You can keep it. If you're working in ProjectWise, you could store it with a number that's maybe like higher 90, since typically we like to deliver our file numbers at the lower end, starting with 01. But if this isn't something you're going to deliver, which you're not going to deliver anything from this file to anybody else, it's just primarily for you to use to extract features using TopoDOT. So you're going to use that seed TopoDOT.dgn seed file that referenced in several webinars in the past. And what that seed file does is it gives you access to the field code levels that you're going to use when you're using the TopoDOT tools. You're then going to extract all those features on those field code levels. And then if there's multiple people working on a project, you can merge all those graphics together into one model maybe. And then you're going to use the TopoDOT feature code export tool to convert all of those graphics that you've merged together, maybe modified in some way if you had to convert them to a CSV file. The second file you're going to create is, if you're working in ProjectWise, is going to be your eWork 01, 2, 3, whatever it is, file. And that's going to be done using the seed 3D seed file. So the seed TopoDOT file that we created in step 1 is going to have all those field code levels. So we do not want to deliver a file with all of those field code levels. All that we want is those existing E levels in our file delivery. So that's why we have to create this second file with just the standard ODOT levels. So in this second file, you're going to create a survey field book, and you're going to import that CSV file that you exported in step 1 into that field book. And that's going to create a bunch of dynamic link features on those proper levels. And then you can make edits as needed. I'm recommending that at this point, you set your elevations to 0. You can make any annotations to elements that you want to. So you'll see in the demo here in a bit that with the TopoDOT tools, you're easily able to get those signed text or even pole text if you have the right image to see it. So you can annotate all that easily with attribute pairs in ORD. And then also setting your terrain model attribute, or TMA, as I have in the list there, to do not include, just because I'm paranoid about somebody taking that data and trying to make a terrain out of it whenever maybe it's not from constrained point clouds. And we know it may not have good elevations. So once you've got all that set up, you can then export your field book as an SQLite for a backup of data if you need it. Not totally necessary, but again, I'm paranoid about losing data. So I would probably do that just to keep a backup in case someone got too click happy for some reason, or an ORD file got corrupted. And then the third file you're going to create is your base file that's going to be up in your base folder. And this is not going to have a field book in it. So in the field book, you can right click on it and export all that to your DGN graphics. And it strips it, leaves the graphics, but strips the field book out. And that's what you would deliver. You are going to have the survey point locators, which we'll see in the demo, but you can easily go in and delete those, and your file should be done. So it seems a little bit cumbersome maybe from the way we've always done it, where you just open up a V8i file, you've got your model, you load your point clouds, extract your features manually, and then you're done. Everything using the task ribbon, everything should have that correct level. But you really had no other way to back it up besides saving the file. It became a little more challenging to keep track of different things. Here, we've also got the option, since we're extracting all this data in 3D on a 3D point cloud, we have this CSV file that we're exporting from the feature code export tool that's going to have elevations on it. And if there's ever scope creep in a project, which never happens, TopoDOT also has a tool to take those graphics that you extract and shift them over to a constrained point cloud. So that's another whole half-day training to get that to work, but just know that that is a possibility. So let's go ahead and jump into a demo here. So my first step was to create a mapping file. I'm going to go ahead and open up an InRoads designer file, ORD. And for my demo purposes, I am not going to put this in ProjectWise. Again, you could put this in ProjectWise. Not necessary. This first step is really just a throwaway file. In fact, I'm not going to do this on ProjectWise. I'm going to rename this. So I'm working on a project, an old project I did up in Region 1. And if you have multiple people, working on this, it's good to keep track of who's doing it. I'm going to set my seed file for this first TopoDOT mapping file to the seed TopoDOT. And again, that's going to give me those field codes as levels. And again, I'm just saving this on my local drive, local C drive. And I'm also going to demonstrate some TopoDOT tools that you can use. If you haven't gotten into TopoDOT, I encourage you to do so. It has a lot of powerful tools that can hopefully make your life easier. So I have created a new file. I've used my seed TopoDOT seed file. And if you notice over here in my level dialog, I have all of our field codes as levels. And that's going to be useful for when we jump into the TopoDOT tools. I also have my existing levels that we've always had. So those are also there. Let me go ahead and start TopoDOT. I'm going to go to my workflows, go to my TopoDOT workflow and hit my start button. I'm going to use our Topo Cloud because I know that this was put on there as a test. So I'm going to go ahead and download my data that way so you can see where this project is at. It's just at the south end of downtown Portland. I'm going to select these 4 tiles. Go ahead and download the selected. And I've already downloaded them to my machine. If I had not downloaded them to my machine previously, this would take a lot longer, but I've already done that. Move this out of the way, fit my screen. I believe I had my point clouds turned off, so I'm going to turn those on. So there's my point clouds that I loaded through TopoDOT. Going to change my display settings. So I want to map this area in 2D. Again, I'm going to extract the striping. I'm going to extract the gutter line. And then I'm going to do the asset or the point features. So signs, poles, luminaires, maybe some trees. So there's really 3 main tools that I'm going to use. So for my striping, I'm going to use extract by intensity. For my barrier or gutter or curb or guardrail, anything that has a consistent pattern, I can use templates. And then for any point features that have any kind of vertical component to them, I'm going to use my asset ID tool. So let's start with the first one, the striping. It's usually the easiest. And I'm in my TopoDOT workflow under my extraction tab. Under my main tools in the topography grouping, I have the extraction by intensity. And I don't intend to get into a lot of detail on these and how they all work. If you want to get into it and haven't yet, reach out to me, or you can press F1 on these tools and it will bring up the help document from TopoDOT. I'm waiting on it to do that because I just pressed F1 right there. So there you have a pretty extensive help section on that. Have the tool active, press F1. It should take you to what they're calling their university page. And there's lots of options here for how to set those. So I want to extract the striping. So you've got 2 tabs. You got the main tab and the options tab. Since we have those field codes as levels, and this is why we created the seed TopoDOT, I want to extract the white stripe. So I can just type in a WHT on my keyboard. It pops up the white stripe there. I can select that. Go back to main. Define the area I want to extract. So I'm setting the intensity values that I want it to look for. And watch it work here. This is a pretty small line, but it's still going to work. So I've got 2 white stripes there, extracted at 15 feet vertices. Took me, I don't know, 20 seconds to do that maybe. With the newest tool, I have the Smart Parallel, which I want to use to kind of move those over into the center. And then I can make a modification to this. Say I want to join those up. So I've got 2 separate lines, but I want to make them one continuous element. Again, there's a tool for that in TopoDOT. And it automatically does that. So I just created a white stripe 15. It did not do it because I did not accept it. Let me try that again. Follow my prompts, left click to accept. So now I have one line, and that line is on the WHT field code level. And you'll see how that's going to come to play as we keep working through this process. So I'm going to go ahead and extract some more. I do have some stuff underneath here that I need to take out. So this is actually a structure, and some of these points below will cause problems. So I'm going to delete a bunch of these real fast or crop them out. Let's go ahead and do this white skip. I can see it's showing up pretty well, the blue colored lines. So again, I can go to my options tab, enter in a WS for white skip, which is our field code. Go back to the main tab. And I like to tell my lines where I want them to end. And I do that by pressing Control on that second direction shot there, going up to the end and saying, well, I want you to end right there. And it just extracted that entire line pretty quickly. Go and do my other white skip over here. It ends, it's pretty short. And then I could go back and do another white stripe over here. Again, I should have done these all as one at one time with the white stripes, but it's pretty easy to go back in and change that. I may need to adjust my intensity values on that line. That looks pretty good. Find my direction. So there is the striping that I'm going to extract. Notice that is on white, WHT. I've got some lines on white skip right there, white skip, another WHT. Let me go ahead and do this dotted line here just to make it a little more complete. We do have a code for that, DOT. And again, this is draping the points to the point cloud. So it is snapping them to the point cloud. So I am getting good elevations here. So we got our striping. I could keep going on and on. I think you get the point on using this extraction by intensity to get your striping. So the next thing I want to do is get my curb and gutter. I know I've got a, change this to RGB real fast, see if that changes anything. So I've got a curb and gutter along the center here, a little median. I've also got another one over here, another little island there. So to extract those, I'm going to use my template tools. And they are under the extraction tab as well. Most of your tools that you're going to use are going to be under the extraction tab. They've got their own drop down for the template tools. And I've already created a template just to kind of show you what that looks like. If I cut a section in this median there, zoom in, I can see my gutter line right there. I've got my curb face and my curb top back. I have already created a template here. Let me load my template library. You can create your own template library with these TopoDOT templates in them, and I do recommend that. So this is the template that I have created. It fits pretty well on this section. I probably made it in a slightly different section, but it does fit in there pretty well. And one of the things I have done is I have set this up to be my top back of curb and this up to be my gutter line. So I'm going to test this template in one section just to make sure it works. If you need guidance on setting up templates, reach out to me. I can help you get that set up. It's pretty easy. Once you do a couple, you can usually do them pretty fast. So let me run a template at a particular cross section just to test it, just to make sure it's going to snap to the point cloud. So on my extract template at cross section, again, you've got different methods for using these template tools. You can do by direction, by path, cross section, and I've never used by fence, but it's an option there. You can set what template you want. Again, this is based upon the cell library that you have loaded. I want this curb and gutter at Arthur Street. It pops that template into the display here. I have a red line signifying that this is the back of the template and a green line signifying that this is the front. If I go define this cross section, notice I have a red line right there and a green line right there where my cursor is. So my green line is on the right-hand side, which is the back of the curve. So I need to flip my template or draw my cross section the other way. I'm going to go flip my template. So right there, now I've got the green line is the back of the template. I'm going to go ahead and define this cross section again. Left click. And notice it gives me a cross section view. And it's a little hard to see. Let me select it. That's still hard to see. Let me change the view to regular intensity. Notice I've got 2 points placed there, one at the gutter and one at the top back of curve. You can also see them in my top view here. So it is working on this curb and gutter. So I'm going to go ahead and use it to extract templates all along this. I'm going to start with this extract template by direction. Again, I need to set my template that I want to use that I've already created. I have other tabs up here. I'm going to step through those once I extract it, but this options, you have an option to allow rotation. So if you're ever going through an area with super, you have to have this checked. And I recommend 10 degrees because you rarely have super over what, maybe 5 or 6. But if you have it at 10, it's going to cover most of that. So it's going to try and keep, if you do not have this checked, it's going to try and keep that template rigid and it's not going to allow it to rotate as your highway rotates. So just keep that in mind. So again, I've got my green and red lines that I have to pay attention to. I'm going to go ahead and run this. So I've got red as my back onto the right-hand side, which is what I have over here. So I am just defining a direction that I want this template to go along that curb and gutter. And it does take a little bit of time, not too much. If it takes a lot of time, usually there's something wrong. So I've done this twice now before the webinar to make sure that this would run on here, and it's always ran. But Oh, there we go. Maybe it just seems to take longer since 20 people are watching. So I've extracted a line, 2 lines, because I had it set up in my template to extract the gutter and the curb top back. Notice this line is on the gutter level and this line is on the curb level for our field codes. So it's gone through here every 15 feet and said, hey, can I place a template here? It's going to drop a template there or add a vertice to the line, and it's going to go on another 15 feet. If it can't find it, it's going to skip ahead another 15 feet and try and find the next one. And it's going to do that 5 times, which is what this error iterations is. I can, visually do it from the top view, just kind of take a look at it. Again, we're not doing this for 3D mapping, so we're not concerned about vertical. But this tool, of course, was built for 3D mapping. So it got all the way pretty much to the end. It couldn't get another 15 feet because that ended. But I can go to this QA/QC tab. I can do a show scores, and it's going to put a series of dots at each one of those vertice points that are color coded. So cool colors. So blues and greens means that TopoDOT felt like there was not a lot of noise there and it could get a good position on that. Warm colors, so orange and red, that's a little bit warm. So maybe TopoDOT was thinking, well, there may be some noise here. You may want to double check this. Again, it's not saying it's bad. It's just saying you may want to double check this. So I can go in and QC it that way. If I were concerned about 3D, this is all 3D related. Again, there is a potential that this could be 3D data later. So you may want to check this stuff. It's pretty quick once you do it a couple times. Most of this is looking pretty good. It's all following along. But I just did, several hundred feet of curb and gutter pretty quickly. You've also got this elevation adjustment tool. Without going into too much detail here on this, it's basically cutting a profile along that curb and gutter that's a foot thick. And you can go in here and see your vertices and make sure they're hitting it vertically. You can move vertices, you can add vertices. You can deal with curb ramps. Again, this is another whole webinar talking about using this tool. So just know that it's there. So if I'm satisfied with that, I'm good to go. I have my curb and gutter extracted there. So that's extract template by direction. So let me go do an extract template by path. And this one, I actually define the path that I want it to follow. And it usually works a little bit faster. So this is what I would tend to use a little bit more unless I had, miles of this to do. So I select my template and go define my path. And I have different path types. Linear seems to work the best in my experience. Again, green is on the left-hand side or the back of the curve. So I want to flip my template. And I just left click for where I want it to go. So again, I'm left clicking, moving. I want to follow this curb and gutter along here. So instead of it having to search, instead of the TopoDOT tool having to search within that broad range of the sample size, it's just going to follow this path and look for that. So I've come to the end. I'm going to right click to start the tool. It's going to drop 57 templates based upon that 15-foot spacing that I have in my search interval right here. And it does seem to go faster using this extract template by path. So it has extracted that. Again, this line is 838 feet. I think that's pretty fast for doing 838 feet of both gutter and curb. And again, if I had like a concrete gutter pan here, I could have thrown that into my template. If I had a sidewalk back here, I could have thrown that in, but sometimes you can make these a little too complex and they won't always work as well. So just keep that in mind. So again, I could do my QA/QC, show scores, confirm it, maybe run my elevation adjustment on that if I were concerned about elevations. But I think I'm good. I could keep going with different curb and gutter. I'm not going to for this process, but you could just keep doing this over and over for all the curb and gutter you got. So that is the template tools that you would use to do features that have a common cross-sectional pattern or profile. So what about point features? The tool to get point features, such as signs and poles, luminaires, different things like that, is asset identification. Let me set up a few things. I'm going to change my display settings from RGB to colored contours. And I like to use colored contours because I can set that contour so that all of these vertical features will stand out from the ground. So I currently have that set to 8 feet. So every 8 feet, I'm going to get a different color in the display. Go ahead and hit apply there. Start at one end or the other. Notice I've got a sign right here. Notice how that kind of stands out. So this asset ID tool, you've got 3 windows here. This first window is a top view, and then these 2 windows are cross-section views. Notice I have an auto picture tab up here. I can load pictures, which I have not loaded my image project. So let me go ahead and load that real fast. Data management, image browser pops up on the other screen. File load project. So these are all of the images from the mobile scanner that I have just loaded in. And you will see how that's beneficial in 1 second. So this tool does use your cell library. So the cell library I currently have loaded is my TopoDOT template cell library. I want to load my regular ODOT existing cell library. So I can just go to my cell library dialog and select that EXTG cell. Loads up all the cells that we're used to. I can hit refresh on this button to activate it within this tool. And I want to get this sign. So I know that the cell name is sign PB for public sign. There's a level override dialog box here. I can input my field code level to assign that field code to this particular cell. You will want to do this. And this tool is self-learning. So you do this once and you're never going to have to do that again unless you wipe out that self-learning file, which is buried in your TopoDOT folder. And I can also enter in a description here for this. I can't see anything yet. So let me go ahead and place on data. Notice I get a magenta circle. I can left click where that sign is. And I get my top view here. I get my 2 cross-section views. I can see that it's slightly slanted. And I've got 2 different, a green dot down here that I'm going to move up because it actually looks for the ground. This tool looks for the ground and then tries to get a height of that. So we're not too concerned about that, but I just want to bring it up so I can see that post in there. And this is a little bit fuzzy, so it's not showing up real well, but that's about the center of that. You can see it in the cross-section views. So I've got my level override set to the field code, and I've got a description here. So this description is actually set up for an attribute pair. I've got a comma, and then I've got my attribute name, which is descript, and then I've got the actual sign text right there. So this is where it's beneficial to use this tool, Asset ID, along with the TopoDOT images. So I don't have to have Google Earth flipping back and forth. I can see it in here. Notice, maybe you can't notice it. Let me close that. On my view 1, turn off those real fast. I have this kind of triangle shaped piece here. This is actually the view location of the camera, what it's looking at. So I need to actually move that back because it's loading the closest image that it thinks is closest to that point that I picked. So I can go up and do a, I can go back another photo and then left. And then I can see that that array is pointed right to that. I can zoom into this photo and see that that is a weight limit and an ahead sign. So I've already put that in here because I did it before. I'm going to add a head. Hit accept, and it updates that description. Go ahead and turn my point clouds back on. Move down to the next sign. Again, I could go to place on data. Everything's set up. I would probably do all my signs at once, come back and do something else. Again, you can see the array of where the image is looking right here. And I can scroll in and see what that actual image is and then change this description. So that's Sheridan Street. And there's a couple more signs on there. I can enter those. Hit accept, and it updates that. And I can keep doing that. Let's say I want to get these aluminum poles or luminaire poles in the middle. Again, I know that the cell name is lumen. You have to learn these somewhat. I would enter in my level, field code level. If I have not done that before, I've done it many times. So it's self-learning and it automatically pops in there. And I could enter in a description if I want. So for luminaires, we do not have attribute pairs. So you don't have to worry about the comma and then the attribute name and then the attribute value. But I can go place on data. Again, it's going to bring up that image. So right there is that image. I can zoom into that luminaire. Sometimes we often have numbers on these luminaires that sometimes people want. This one doesn't seem to have one unless it's on the other side. Sometimes you can see that. This is not a luminaire, it's a pole. Why did I say it was a luminaire? So pole, aluminum. Again, I can enter in my code, any kind of description. Let me go ahead and place that on the data there. And then I'll delete that luminaire. Let me go back to the luminaire. And I know that that's I can see that that's one of the new LED lights. So maybe I want to put that in the description. Maybe somebody has requested to know that. Can accept it, and I can keep doing that through the whole project. Here's a tree. Maybe I want to put in a tree. Again, I can just type in for that cell name. I've already done a level override or the field code level, and I know that trees have attribute pairs. Again, I can go to my Open Roads survey manual to get the features that have attribute pairs. Go ahead and place that on the data. And one of the benefits of doing this is that I can actually get a diameter of a tree. Probably not too important for 2D mapping, but for 3D mapping, it's important. I can adjust this, this diameter of this circle. Notice it gives me a radius. I have a %D in here, it reads that, and it puts it in the text file that we're about to create. So I've got those features. Again, I can do this for the whole file. I'm going to run out of time. So I've extracted all my features. If you have multiple people working on different pieces of this, maybe once everybody's done, you would then merge all those graphics into one file before you moved on to this next step. So our next step is to create a CSV file of all these features. So to do that, TopoDOT has a tool called Feature Code Export. It is under the Export tab. It's a big FC, Feature Code Export tool. I can select that. There are some options that you need to set up, and I have another document that has all these options. There's also a file that you can copy from our share drive that will set these options for you automatically. And another couple of CSV files that you can load up that will give you all these field codes and these dropdowns. So if you want to do this, reach out to me and I can help you get that set up. You have two tabs. You have a manual tab. So I could do each one of these manually, or I could go up to the auto tab if I know I wanted to bring everything in, which is probably what you're going to be doing most of the time. You can set a point number and a stringing ID on all of these features if you want. If you have multiple people working on something, this could be useful to do. Maybe one person starts with 100,000, the other person starts with, I don't know, 110,000, just another way to keep things organized. But to get to that, you have to hit this clear button, and it allows you to set the current index, or what we would call point number. I'm going to start with 100,000, and then this feature code index is what we would call a stringing ID. For each one of those lines, they have a ID added to the field code. Maybe I was assigned 100. I have my levels in here. These are all my field code levels, and then a feature code. So this feature code is just a duplicate of our field code levels. I'm going to go ahead and hit process. And all of these graphics that were in my file and on those particular levels have now been assigned a feature code based upon this list up here. I've also got some descriptions in here. Notice that's set to old. Maybe I described that as an old pole. I can keep going down through all of these. Here's the tree, or some signs that I had. So those descriptions carry over into this as well. So with that, I can hit the save button, and I'm going to save this as a CSV file. And, multiple people, you want to make sure you're keeping your file straight. Make sure everybody knows this is just for 2D data, since you're not doing it from constrained point clouds, maybe. Go ahead and hit save. I've already done it once. I'm going to replace that one. So I say yes. And nothing seems to happen. But it does save it. You do have to go manually open it. And here's what you get. Same thing we saw in this preview box. So you get a point number that we assigned. You get your northern, eastern elevation, and then your field code with that stringing ID of, we started with 100. So here's our aluminum pole, starts at 100. We had 2 of them, there's 101. Here's our curb. Oh, I left some points in there, so I could delete that. But we've got our curb, again, 100, the start code, and then an end code on that. And let me point out this aluminum pole. All we did was put a description since we didn't have an attribute pair. Notice it comes in right after the field code. And then if I scroll down to those signs, we're using attribute pairs. So there's a blank here. That's what that comma was for in my tool before the word descript, to leave that blank for any descriptions that may be in here. And then I've got my attribute name and my attribute value in that. And for my tree, again, I've got my attribute name, attribute value, and then I've got a second attribute called diameter inch, and then the value that it pulled from that tool. So pretty handy. So to bring this into my next file, I need to add a header to it. Unfortunately, the tool in TopoDOT does not add a header. So I'm going to call that point ID, northern, eastern, elevation, code, note. I know that's attribute name, attribute value, attribute name, and attribute value. I'm going to go ahead and save that. Close out of it. If you leave it open, it will not import correctly into your next file. It will not import at all. So I now need to create a new file, a new working file. And this is going to be, if you're working in ProjectWise, this is going to be the, eWork 005 or whatever number you're at. We're going to bump it up to 6. And this is where I would want to choose that seed file as seed 3D, because we don't want all of those field code levels in this file. So my new file has loaded. Maybe this file is in my survey folder in ProjectWise. And I need to create a new field book here. So I can go to my survey workflow, go to field book, go to new field book. This is going to be I would want to name it something that's appropriate to make it clear that this is only 2D mapping. And now I need to import that CSV file that I just exported from that previous file. So to do that, I can right click on my fieldbook name, do an import, and import file using the text import wizard. That's my particular file that I did. I'm going to go ahead and open that because it's going to open up the wizard. And if I had not added my header into that CSV file, those points that are farther down below with the descriptions and attribute pairs would not be able to be imported. So I have to add that header in there for this to work. So I can step through this wizard. It is comma delimited. I need to assign my column names. Again, I wouldn't want to do this every time, so I would probably save one of these to your machine. So that's all set up correct. Northern, eastern elevation code note. Yeah. Go ahead and hit finish. Again, I could create this and save it. So I've then brought those features in. And one of the benefits of doing this is that this sign has all that information assigned to it as an attribute pair. Let me drill into this, show that there. Again, I can delete that header line that I had on there that I had to use for the text import wizard. So let me go ahead and delete that since I see it. Go down to my signs, show you these attribute pairs that have automatically assigned description, weight limit and a head, and then the different descriptions there. So the benefit of doing that is I can go up to this drawing production. I can do an element or model annotation. I don't have many things here to annotate, so I'm just going to do a model. And it does the whole model. And notice my trees have the diameters if that was a thing for your 2D mapping. Again, this could also be used for 3D mapping. So that's pretty convenient to have there. So at this point, this is still my working file. So I have, if I needed this 3D data in the future, I still have those CSV files with all the points in it with elevations. So at this point, I'm going to set all my elevations to 0 using my survey details dialog and selecting all my point features. Just set everything to 0. And because I'm paranoid about someone maybe using this data to make a terrain, I'm also going to set that terrain model attribute to do not include. And if I wanted to add any other attribute pairs at this point, I could add my VBA macros to rotate any signs or anything else I needed rotated, maybe some arrows, different things like that. Again, beyond the scope of this webinar, but reach out if you get to that point and I can help you out with that. So if I rotate this down onto my front view, notice everything's flattened, but I'm in a 3D file and I've got everything in my field book. At this point, I could save this field book as an SQLite as a backup, or maybe to share with someone else, maybe for merging later. But I want to create my base file that I'm going to deliver to someone. And let me add a little bit of text in here. So if I go to my ODOT survey ribbon, it's one of the things we always did. Go to my general features, street name text. I know that that's Front Street. Can place it there. I know the Sheridan Street was up here. Again, I would rotate this. So at this point, I've got everything flattened to 0. I've got everything annotated that I want annotated. I've got all my VBA macros set in there correctly. I can right click on this field book name, export to DGN graphics. And this is going to be my base file that I'm going to make. I've already done this. It's going to be ebase 06. And yes, it will be a base file. It's not going to have any kind of terrain or fieldbook data in it. So it will go in that number 3 base files base folder. Go ahead and save that. And it should automatically open. Fit my view. So I've now got plain features that are annotated. My field book is no longer there, which, you know, the person using this probably doesn't need the field book information. One of the things I am going to have is all these point locators. Again, I can very easily delete all those because they're really not needed in the file I'm delivering. Select them all. There's 327 of them. Delete. And one of the things I wanted to put this text in here was to show you that even though this wasn't in the field book, this came across when I exported the field book from DGN Graphics. So that is the general process. So this file should be ready to deliver should you want to do it. So yeah, I mentioned the schedule earlier. So what we have is going to take us pretty much to the end of the year with these 4 topics. If you guys come up to us and say, hey, I'd really like to know about this or this, you know, we may change some of that, but until we hear from you, this is what it's going to be. So thank you all for attending.